Hello everyone, my name is Diego Ricino and I'm a team member for Group 11. And today I'm going to demonstrate our senior design project. Our team members are Grip Miller, Grace Brazil, and also Gustavo Diaz. In this presentation, we will only going to show how the device works, and we will not go into further technical details. For those details, please refer back to our website and also to our presentation. This is the PCB for our device. As you can see, it's actually without the enclosure. This device has different sensors either soldered on the board or actually attached to this connector here. Our heart rate sensor is seen below here, and all the different sensors are actually attached to this connector. Seen here. We have the GSR sensor here, and we also have the temperature sensor here along with the battery as well. Now I'll go ahead and plug in the connector that will actually power the device. Now I would like to demonstrate that the battery is completely self-powered through the connector, as you can see here. And for that, I would like to use a multimeter. The voltage range of the battery is 3.3 or 4.2. So I'm just gonna measure from here, which is ground, down to this probe here. And as you can see, it's 3.65. And the reason why is because it's it's not completely empty, but it has been used before. Now I would like to demonstrate the charging. And for that, I would like to connect it with the micro USB to the micro USB port. And as you can see, it turns green to indicate that it's currently charging. The voltage will rise up to 4.2, 4.4, or sometimes 4, depending on what the battery needs. So as you can see here, if I do this here, from ground to this probe here, is 3.9 and it's indicating charging, and once it's completely charged, this LED will turn off. Now I would like to bring the attention to the next component for this device. We have a microcontroller, which is the ESP32. We actually have the WRROM module here, and this actually connects through Bluetooth to our phone app that we currently have here. So this is a Motorola device with Android, and we have this app. So when you click on this, it will say waiting, and then automatically will connect to our device. Then it will pull all the values like the heart rate sensor, the temperature, and also our GSR.
The mobile app will now be demonstrated. Its two main features are a dashboard and a notifications activity. The dashboard shows the 3 sensor values displayed and updated in real time in this area of the UI. Also included is a calibration button that will begin a calibration period when pressed, where received data is stored. Once the calibration period is ended after a second press of the calibration button, the stored data is then used to determine value thresholds for all 3 sensor values. An important thing to note, the longer the user allows for calibration, the more accurate these thresholds will be. The notifications activity of the mobile app is responsible for pushing alert notifications to the user that alerts the user of the device whenever any of the biosignals being received are outside of the calibrated threshold. This notification will state that it has detected that the user may be under possible stress, showing which sensor it came from. When the alert notification is pressed, it will take the user to the app notifications, which shows a history of timestamp past notifications from most recent to least recent. It is worth noting that existing features can be edited quickly and easily due to many of them relying on sensor data, as it is saved as they are being received in a JSON format on the user's mobile device.
Now I would like to demonstrate the first sensor on this device, and that is the heart rate sensor. This heart rate sensor is mounted on the back of the board, as you can see here, and is mounted through a wristband to apply firm pressure on the sensor. As you can see, the values update in real time on the app on this little square here. And to further demonstrate that it's updated in real time, I would like to compare it with a commercial product, which is the Galaxy S9 with the heart rate sensor in the back. This is an app that actually can show, based on the laser in the back, what's my heart rate. So for that, I would like to demonstrate as I actually breathe heavily for a couple of seconds. And you will see the values, both values go up, like so. As you can see, the values updated in real time. Yeah, I'm sorry if I'm short of breath, but it takes a little while to update it on the actual phone. And as you can see, we're within the 10% range of accuracy. And to further demonstrate that it's actually working, I would like to just place it here, like so. Again, actually measuring the heart rate more accurately. So you can also see I'm also having issues with the sensor here. So the phone can update the real values, but I'm having issues with the phone. Now I would like to explain the following sensor, which is the galvanic skin response sensor hardware, and it's attached to my hand with these two probes, and all the processing is done on this area here. I will now show for the app demonstration, I would like to also show how these values change over time. So once again, I'm going to breathe heavily to show that these values will go down as I breathe heavily, and that's due to, as you get more anxious, your hands tend to sweat a little bit, and that can actually cause an inflection or downward current on the resistance. So I'm gonna just breathe heavily. And as you can see, as I get more anxious, my palms get more sweaty, and I can feel the sweat and the clammy feeling in my hands, and that's what makes the GSR go down even low. As you can see, that was part of our engineering requirements to make sure that it was going down at a rate in real time. The final sensor that I would like to demonstrate is actually the thermistor, and also the app receives this information. These are real temperature values. The temperature is actually measured by a thermistor in the back, as you can see here. And also, I also have it plugged into a thermocouple thermometer. And this is a commercial product. And as you can see, the values are similar. And just to show that the values are within the 5% or, the 10% engineering requirements, I'm just gonna air out the sensors here. I'm sorry because it's attached to my hand. Go like so. And the probes kind of disappear a little bit. And you can see how the values are accurate to within the same degree. Oh, sorry. So this is not room temperature and is decreasing both at the same rate. Overall, we managed to accomplish all the different goals that we wanted for this project due to the circumstances. But we would like to thank you for looking at our demonstration, and if you have any more questions, please refer back to our website. Thank you very much. Due to the current global situation, we have a lot of hurdles of developing this device. The most obvious one was delays for components and also for PCB manufacturing. But also we had problems accessing different equipment that we needed to debug this device. One of the biggest problems that we had, or one of the features that we wanted to implement, but not really no requirements, was to have the USB to serial interface. And unfortunately, due to the lack of equipment, we didn't have enough time to debug completely what was happening. Thankfully, we had a workaround so we could program the device. Also, there was different parts on the PCB that were not laid out properly, but it did not affect the overall design or the overall functioning of this board.